God. Okay. So today we are going to discuss the basics laws. Okay, basic law which make foundation of circuit analysis. Okay, so the first is Ohm's law. Okay, so we know that every material has a property that it opposes the current. Okay, so suppose we have one conductor. Okay, see this length is L and its cross section area is A. Okay, so when I allow current in this conductor, okay, so this current will resist this current. Okay, I. So and the resistance, the property by which is resist, okay, called resistance, and resistance of a conductor is given by it is proportional to its length and inversely proportional to its area. Okay, if we combine this both, so this is equal to rho L upon A, where rho is the resistivity of the material. Okay, and its unit is resistivity unit is ohm into meter. Okay, resistivity is the material properties. For example, if I take conductor, good conductor like silver and gold, okay, so their resistivity is in the order of 10 to the power minus 8 ohm per meter. Okay, similarly, if I take an insulator, a good insulator, okay, so they are around 10 to the power 15 ohm per meter. So resistivity values for insulators are very high. Now if I take example of semiconductor, okay, so semiconductor has intermediate values. Okay, so for example, if I take silicon, so the resistivity for silicon is 10 to the power 2 ohm per meter. Okay, this is for silicon. Similarly, if I take gallium, so gallium has a lesser band gap, so it has a somewhat lesser value. So if I take, for example, germanium, for the value is 10 to the power minus 2 ohm into meter. So conductors have a low resistivity, while insulator has a very high resistivity, and the value of semiconductor is intermediate between them. Okay, so when I apply current in the material, okay, so the circuit symbol for this resistance is R. So when I apply current inside this, so there will be voltage drop. There will be voltage drop, and this voltage drop is proportional to the current, and so we can write V equal to IR. So this is your Ohm's law. So when you apply this Ohm's law in the circuit, you have to take care of the sign, okay, where the current is entering. Okay, if the current is entering to positive terminal, so you can write V is equal to IR. If current is entering to minus terminal, if this current entering to minus terminal, then you have to write Ohm's law as minus IR. So when you are applying this law, you have to take care of the direction of the polarities. Okay, so similarly, now sometime you have the element which resistance is very zero. Okay, that is called short circuit. Okay, so for example, I have one circuit. Okay, so this is the load, external terminals. So if I connect,
Sir, sir, your screen is too bright, sir.
okay, just give me 1 minute.
Sir, it is blurry also.
Sir, you are too fast, sir.
Is it okay now?
No, sir.
Okay, just 1 second. Is it okay? Now it is visible.
Yes, sir.
Okay, thank you. So now the short circuit. Okay, short circuit means an element whose resistance is almost negligible. Okay, zero. So if I add one wire, connecting wire here, okay, so his resistance will be zero. So resistance is zero. So voltage drop across this short circuit will be also zero, but current will be flowing. Okay, so across short circuit, current will be flowing. Okay, but because the resistance is zero means it is negligible. We cannot say zero, it is almost zero. We can neglect. So voltage drop will be also negligible. So we say it is zero. Okay. Similarly, this is short circuit. Okay. Now, what is open circuit? Sometime we will also encounter open circuit also in our circuits. Now, what is open circuit? So open means there will be no current is flowing. Open means the resistance is very high. Okay, open means the R value is very high, infinite. That's why your current is zero, but there will be voltage. Okay, voltage will not be zero. For example, for voltage you don't need a resistance. For example, battery, they are terminal, they are separated, but there is a voltage. So in open circuit you will have a voltage, but current will be zero. Okay, so this is for open circuit. Okay, now so Ohm's law says the V is equal to IR. Okay, so if I plot a graph between V and I, okay, so this should be a straight line. So this should show linear behavior. Okay, so in experimentally this is true only for some given voltage only. Okay, your resistance, even if a connector, it will not show this straight line, but for a range it will show like linear, like this linear behavior. Okay, so suppose I have three resistance. This is R1, say this is R2, and this is R3. So if I take this voltage here, okay, so for this voltage, this is the current value. Okay, for this curve, this is the current value, and for this is the current value. So say this is I1, this is I2, and this is I3. Okay, so from we are applying same voltage for this curve, I'm getting less current. That means this R1 is greater than R2 is greater than R3. So जैसे जैसे R बढ़ता जाएगा, इसका स्लोप भी, ग्राफ का स्लोप भी इंक्रीज होता जाएगा. Okay, now this is Ohm's law.
Sir.
हाँ.
Sir, is it possible to flow the current if resistance is zero?
Resistance is zero.
Yes,
so
sir.
resistance zero तो सुपर कनेक्टर्स के लिए होता है, that low temperature. Okay.
Okay, sir.
Generally you don't have resistance zero. Okay.
Like sir, अगर resistance मतलब काफी low होता है सर, तो हमारा potential difference create नहीं होना चाहिए ना Ohm's law के according, like V equals to IR वाला.
हाँ, तो कम होगा, उतना ही कम होगा. रेजिस्टेंस कम है, करंट भी देखना पड़ेगा. ओके, नाउ सुपर कंडक्टर्स में क्या होता है, आपका रेजिस्टेंस बहुत लो हो जाता है, बट देन यू अप्लाई करंट. ओके, बट देन यू हैव टू कीप द करंट आल्सो लो, क्योंकि अगर करंट जैसे आप बढ़ा दोगे तो सुपर कंडक्टिंग टेंशन फेल हो जाएगा, दैट इट विल गो अगेन टू नॉर्मल स्टेज, बिकॉज यू आर इंक्रीजिंग करंट, दैट विल इंक्रीज द टेम्परेचर, सो योर मटेरियल विल अगेन गो बैक टू द नॉर्मल स्टेट. So that you are asking some imaginary question. Okay, so but if his resistance is very low, you have to see the current, because V is equal to IR. Okay, now so now you're saying if R is very low. Okay, so and current value is also, so current value cannot be very higher. You cannot take current value like 10 raised to power 12 ampere. That's value you cannot take. Okay, so because suppose resistance is 10 raised to power 12 ohms. Okay, so your current value will be very 5 ampere, 10 ampere. So compared to then it is if 10 raised to minus 12 ohm. Okay, then there will be negligible voltage, zero. There will be zero voltage if this is very very low. Okay.
Yes.
So now if you know Ohm's law, we can also calculate power. We know power is equal to IV. Okay, so this will be equal to I square upon R or V square by R. So if you know the so you see power is not a linear function. Okay, it varies as a square. That's why whether it's a voltage is negative or positive, you will get always power positive, power value positive for resistance. That's why resistances are passive elements. Passive elements R is passive element. That means it will in a circuit it will always absorb the power. Okay, this will not generate any power in the circuit. So this is all about resistance. Okay, now we'll start our Kirchoff's law. So Kirchoff's current law. Okay, so Kirchoff's current law says that the algebraic sum of currents entering at a node is 0. Okay, so for example, I have this node P. Okay, so this IA current is coming here, this is IB current, and this is IC current, and this is ID current. Okay, so this law says that current entering or leaving. Okay, so I'm doing for entering currents. So current entering for a node, the sum of the current entering a node should be 0. Okay, and this is because of conservation of charge. Okay, because in circuit node is a point which cannot generate charge. So जितना charge आ रहा है उतना charge वापस भी जाना चाहिए. So that's why because of charge condition of charge conservation, we can write IA plus IB minus IC minus ID equal to 0, because I am taking now entering current as a positive and leaving current as a negative. So I can write IA plus IB equal to IC plus ID. That means these are the current coming towards the node. Okay, entering currents, and this is your outgoing current. Okay, or leaving current, outgoing current from or leaving current. Okay, so I have written for this for entering current. Okay, you can also write for leaving currents. Okay, so if you're writing for leaving currents, then leaving current will be positive, and coming and the currents which are coming towards the node, that will be taken negative. Okay, both will give you same results. So this is only sign convention. So now we'll see how to apply this KCL in problems. Okay, so one more thing. If in a circuit I have more than one current source, suppose this is my circuit. Okay, so this is I1, this is I2, and this is my I3. Okay, and the total current in the circuit is IT. Okay, so this type of if their sources are connected in parallel, so this is a single node. Okay, you can see there is no resistance between these terminals. So this is single node. Okay, so if these Vandana, just see. Hello, Vandana. So
हाँ जी सर.
ये थोड़ा बंद कर दो उसको, अनम्यूट कर दो, म्यूट कर दो उसको. So you see these are sources. Okay, these sources are connected in parallel. So I can replace this circuit by equivalent circuit which has only one source. Okay, so one source which is giving total current IT equal to I1. Okay, this is reverse current, this is current in opposite direction, minus I2 and plus I3. So wherever in the circuit, this is equivalent circuit. Okay, So if you find more than one sources connected in parallel, so you can combine them and you can write as a one source in the problems. So I'm solving one problem now. So I have given one circuit. This is plus minus 10 volt. So I have one more resistance here. So this is R1, this is R2, and this is R3. And this is resistance. So this is 5 amp current. Okay. So here say circuit is given. So this is 3 ampere current. This is 2 ampere current. And we have to calculate current in this R3. Say this is R3. I have to calculate. Okay. So from the circuit, you can see how many nodes are there in the circuit. How many nodes are there? कितने नोड है सर्किट में?
4.
You know? कितने? 3. So this is the node, one node. This is also single node. Okay. And this is also this 4 terminal is a single node. So there are 3 nodes. Okay. If you say branch, there's 1, 2, 3, 4, 5 branches because 5 components are there. Okay. So now I'm applying KCL at this node. Say this node is full node is A. So I'm applying KCL at node A. So what is the value of I3? So this 3 ampere current, okay, this is a single node. The 3 ampere current is coming here. So this will be positive 3 ampere current, okay. 2 ampere current is leaving, -2, okay. I3 is leaving, -I3, and 5 ampere current is coming towards the node. So I can write 5. So should be 0, okay. KCL at node A. So if I apply KCL, so it will give how much? It will give me I3 equal to कितना आएगा? I3 equal to -6 or +6?
Sorry, 6.
But this will be 6 ampere. Okay. So this way we can apply KCL in the circuit, and this type of KCL will be very useful when we will do op-amp. Okay. So let me solve one more problem. इसको रब कर दूं?
Node A पे क्या you have used KCL?
At node A.
Okay, sir. 2
Okay.
and I3 are going outside, and 3 and 5 are
3 and 5 are
going to
coming
A.
towards node. Okay.
Yes,
And
sir.
2 and I3 are leaving. So from here I can
Okay,
calculate
sir.
what is the value I3. Okay,
Okay,
good.
sir.
Okay, so let me solve one more problem. So we are here trying to learn, okay, how we will apply these laws in circuits. Okay, so I'm giving a simple problem so that you can have some practice. So this is 18 volt. Okay, this is the 6 ohm. Oh, sorry, this is 6 ohm. This is 5 ohm, and this is given as RA. This circuit is giving 8 ampere current. This battery is giving 8 ampere current, and we have 3 ampere current in 6 ohm, and our Vx is giving 13 ampere current. Okay. Now you have to calculate what is the value of this resistance. Okay. So first of all, let us check how many nodes are there in circuit. Nodes kitne? So this is one. Okay. This is other node. Okay. Say this is A node. Say this is node B, and this is, so A is already written. So this is A, B. This is C. Okay. So we have total 3 nodes. Okay. Branches 1, 2, 3, 4, 5. 5 branches.
Sir. Sir, can you please again tell आप nodes कैसे recognize करते हैं?
फिर nodes कैसे करते हैं? देखो, nodes की definition क्या है? A terminal where 2 or more components join. Okay. So यहाँ पे देखो, यहाँ पे this terminal, यहाँ पे दो component join हो रहे हैं. These 2 components get joined. So this is a node. Okay.
Yes, sir.
Now these are short circuit. So we cannot. So this is single node. Okay. So in this point पे दो component join हो रहे हैं. So this is a node. Okay. But since this is connected by short circuit, or this is same thing. यहाँ पर voltage V है, यहाँ पे voltage V होगा, यहाँ पे voltage V होगा, because they are short circuited. Okay. So that will be a single node. Okay. Similarly, this full is a single node.
Yes, sir.
Okay. Single node का मतलब क्या है? वोल्टेज सेम होना चाहिए. If there is no voltage drop, यहाँ पर जो वोल्टेज होगा या रेजिस्टेंस नहीं है, तो जो वोल्टेज इतना यहाँ पर होगा वो इतना यहाँ पर आएगा. That's why this will be considered as a short circuit, as a single node. Okay. Now I want to find out what is the value of RA. What is the value of RA? How to calculate? First tell me what is the value of Vx here. Okay. So you can see here, this is the 18 volts. Okay. This is 18 volt, and there is no resistance. And this is also parallel. So I want to find out RA. So this is so here also voltage is 18 volts. So this is 18 volts. Okay. Now I want only current. If I know current, say this current is IA. So if I know the current IA, I can find out what is the resistance. Now in order to find out IA, you can apply KCL again. So see, this is 18 volts. This is parallel. This is also 18 volts. And you can see this is 6 into 3. This is again 18 volts. So because these 3 branches are parallel, so they should have a same voltage. Okay. Now you can apply KCL. So if you apply KCL at node B, okay, KCL at node B, okay. So node B पे 13 ampere current is coming. Okay, 8 ampere current is coming. 8. Okay.
8 plus 13 plus
IA minus 3 and plus 13 equals to 0. So IA कितना आ जाएगा? What is the value of IA?
18.
Okay, very good. 18. Okay. So IA is 18 ampere. So resistance is 18. Current is also 18. So this becomes 1 ohm. So your resistance is 1 ohm. Okay. So this is what's your KCL. We'll do some more problems. So now first, let me start now KVL.
So Vx also we have to find, na?
Vx, okay, that is homework. If you can find out Vx, find out. Okay, that will be homework. So you can apply KVL and you can find out. So first we see how to apply KVL and then you can find out. So Kirchoff voltage law. So Kirchoff law, voltage law says KVL. The algebraic sum of voltages across a closed path is 0. Okay. So So suppose I have given a closed path. This is my voltage. Okay, so this is V1. Here I have a resistance R1, and again I have a resistance R2. Here I have battery minus say plus, and here I have some component here. Okay, so I have been given this voltage drop. Here is V1. Here voltage drop is V2. Here voltage drop is V3. Is here voltage drop is V4, and here voltage drop is V5. Okay, so so I know that these voltages. So now KVL says the algebraic sum of voltages across a closed path is 0. Okay, so if I write now equation for this one, now when you go from minus to plus, that will be a rise in potential. Okay, and when you go from positive to negative, okay, that means there is a drop in potential. So while writing KVL, it is your choice, okay, whether you want to take a voltage drop as a negative or voltage rise as a negative. Okay, so you can take voltage rise also positive, you can take voltage drop also negative. But if you are taking voltage rise as a positive, then voltage drop will be negative. Okay, so I'll show you. So suppose I am taking voltage rise as a positive first. So how to write? So this will be positive, this will be V1. Okay, so this is voltage, since this is a rise, negative to plus, so this will be positive. Now this is drop, so I will take it minus V2. Similarly, this is also drop, so I will take it as a minus. Now again, this is a rise, so I will take it as a positive V4. And at last, this is also drop, so I'll take it as a minus V5. So I can write now V1 plus V4 equal to V3 plus V4 plus V5. Okay, that means now sum of voltage rise. Okay, sum of voltage rise.
It will be minus V5, no? So,
Which one?
okay, sir.
So equal में लिखा ना, उधर भेज
Yes,
देना.
sir. Okay.
This should
sir.
be 0. Okay, so sum of voltage
तो
voltage
सर
rise equal
V2
to
होना है सर, V2 होना है सर, V4 नहीं, V4 तो राइज हो रहा है.
V1 राइज हो रहा है, V4 भी राइज हो रहा है.
हाँ सर,
ठीक है,
हाँ
ये
सर.
ड्रॉप हो रहा है, ये भी ड्रॉप हो रहा है, ये भी ड्रॉप
Yes.
हो रहा है. सो V2 V3 and V5. Okay,
और V5 अब
ठीक
ठीक
है.
है सर.
हाँ, तो sum of voltage rise equal to sum of voltage drops. So एक तो तरीका ये लिखने का है. Okay, and the second method is you take a voltage rise as negative. Okay, तो वो ज्यादा आसान है. उसमें क्या होगा, जो टर्मिनल आपको मिल रहा है वो साइन देना आपको. If I take voltage rise as a negative and voltage drop as a positive, then it is very easy to remember. It is your choice how do you want to do. So अगर मैं इसको लूँ positive negative, okay, so this will be minus. तो जो टर्मिनल मिलेगा वो साइन. So यहाँ पे टर्मिनल प्लस है, this will be V2. Okay, here sign is terminal is plus, so this will be plus. So here minus, so minus V4, here plus, so should be 0. And again, if you see, this will be same. V1 plus V4 equal to V2 plus V3 plus V5. So same result आएगा. So अब ये this is your choice. How you do. I do voltage rise as a positive. Okay, you can take voltage rise as a negative also. So now we will solve one problem so that you know how to apply this law in a circuit. So I was given a circuit. Say this is my 20 volts. This is 2 ohm. And this is my 3 ohm. Okay. So here the voltage is given plus minus V1. And here they are given minus plus V2. This is already given in the circuit. Okay. So this is 2 ohm. And this is 3 ohm. and they're asking find V1 and V2. Okay, so find V1 and V2. Okay, so say how to write. So write KVL. Say we are going clockwise. Say current is I. Okay, so current I is flowing. Now I can write KVL. So 20. Okay, I'm taking it positive, or if you are comfortable with minus, so minus to minus, so minus 20. Okay, minus V1. So now plus V1. Okay, now again it's coming minus, so minus V2. This sum should be 0. Okay, now what is V1 and V2? What is V1 here? So V1 is 2I. Okay, because resistance into current 2I. And what is V2? V2 कितना होगा?
3I.
3I or minus 3I?
Sir, minus 3I.
Minus 3I, because I told you in Ohm's law, you have to see if current is coming from positive here, then you take Ohm's law is V is equal to IR. If it is going from negative, and current is going to negative to positive, then you take minus R. So now you can put the values here. So minus 20, so V1 is 2I. This become 3I equal to 0. So 5I equal to 20, and this will give you I equal to 4 ampere. Okay, so you know I equal to 4 ampere. So your V1 become 8 volts, and your V2 is minus 12 volt. Okay, so now I'm giving one question more, so you need to solve this. Okay, so we have a circuit. This is 60 volt. Here we have 10 ohm resistance. Here this is 8 ohm resistance. Okay, and 5 ampere current is coming here. Now you have to apply both KCL and KVL together. Then only you will be able to solve this one. So this is 4 ohm, and this is your 2 ohm resistance. And here current is IX, and this is your Vx. Okay, so find Vx. To find the value of Vx. Okay, now how can you find Vx? So Vx is parallel to this one. So if you know current in 2 ohm resistance, if you know I2, okay, if you know I2, then you can calculate, you can multiply, and you can find Vx. Okay, so say this is current is 5 ampere current is coming. Okay, so this is I8. Suppose this is I8 current, because it is flowing from 8 ohm. It's I8. Okay, and this is your I10 current. Okay, this is your I4 current. So now you want I2. Okay, so solve it now. So first of all, what we'll do, we'll apply, say this is here plus minus. So say this is V10, this is 10 ohm resistance. Okay, so this is V10. Say this is V8, this is V8, this is 8 ohm resistance, and apply KVL here. Okay, because ये आपको पता है ऑलरेडी. ओके, यहाँ करंट पता है, यहाँ का रेजिस्टेंस पता है, तो ये वोल्टेज पता है, ये वोल्टेज पता है, then you can find what is V10. Once you know V10, you have given resistance, you can find I10. Okay, I'm repeating again. ये वोल्टेज आपको पता है, if this KVL you know this voltage, okay. यहाँ पे आपको करंट भी पता है, रेजिस्टेंस भी पता है 8 ohm, okay. So this voltage also you know. So now you can find out what is V10. Once you know V10, you know resistance, you can find I10. So you know this current, you know this current, okay. So you know both current, so you can calculate what is I4, okay. So now then again you can apply KVL here. Now you know this voltage, you know this voltage, you can find out this voltage. Once you know this voltage, you can divide by resistance, you can calculate current, okay. And you can directly calculate this voltage, okay. So now apply KVL in first loop, okay. Say this is I, so I can write this 60 minus 60, okay, and this plus V8 and plus V10 is equal to 0. So minus 60 plus V8. V8 is 5 into 8 ohm, 40 volts. So this will be V10. So V10 will be equals to 20 volts. Okay. Now I10 will be, I10 कितना हो जाएगा?
I10 will be 2 ampere.
So this will be 2 ampere. Okay. So now this is 5 ampere. This is 2 ampere. Okay. So what is the value of I4?
3.
So I4 is now 3 ampere. Okay. So again, you can apply KVL here and calculate what is V2, how much voltage is dropping here. So if you again apply here, so this is minus, okay. So minus V10 plus V4. If you say this is V4, huh? This is V4, and this is plus minus, this is V2, okay, and plus V2 equals to 0, okay. Now V10 value already we calculate 20.
Sir, how I4 is 3 ampere?
I4, okay. So 5 ampere is coming from here in this node, okay. We apply KCL here.
Yes.
5 से आ रहा है, और here we calculate this value 2. So 5 minus 2 it will be 3.
Okay, sorry.
So this will be 20, okay. Now so you want V2 now, 20 plus V4, okay, and V4 is how much? V4 is 12, 4 ohm into 3, 12 plus V2 is to 0. So your V2 will be now 8 volts. So your V2 is equal to Vx because both are parallel, okay. So this is the value of Vx, 8 volts. Okay, let me take one last problem. So it will going to take 10 minutes. So I think now you know how to apply KCL and KVL, okay. So I'm giving slightly heavy problem, so you can apply and you can calculate, okay. So suppose this is plus minus 30 volts, okay. This is 8 ohm and this is 3 ohm.
Sir, in last question, I2 is 4.
Last question में क्या था?
I2 4 था.
हाँ, I2 4. मैम हमने डायरेक्ट V2 निकाल लिया था ना, हमें डायरेक्ट V2 निकाल लिया था. So if you say it is why it is 4, okay, Ix का वैल्यू तो पता नहीं है हमको ना.
Yes,
the 3 ampere current coming, that means Ix is 1.
Okay, sir.
Okay.
तो Vx 8 आया था ना sir?
हाँ. So
okay, sir.
So we asked only Vx, we didn't ask Ix. Okay. Okay.
Okay, sir. Okay.
So 3 ohm. So this is, I think, 6 ohm. Okay, 6 ohm. Okay. So 3 ohm, 6 ohm. So I1, I1 current is coming here. Okay. I2 is going here. And I3 is going here. Okay. No more information. Okay. So now you have to calculate. Okay, all you have to calculate. Suppose this is V8, V1. So this is V1. Say this is V2, and say this is
I1 is 10.
okay. So I1 is not given. Okay, you can calculate.
10.
So how it will come 10? So you find out I1, just 1 minute, I2, I3, V1, V2 and V3. So you have to 6 unknowns you have to calculate. हाँ कैसे बोल I1 10 कैसे आएगा?
Sir, 6 or 3 in parallel, so 2. 6 or 3 in
6 and 3 are
parallel. So
okay.
to
So you
8 and
okay
2,
you are calculating like this way. Okay, you can, so that's why so far we have not done this series and parallel circuit. Okay, so I'm asking you to only apply this KCL and KVL. Okay, one circuit can be solved
yes,
many
sir,
ways.
but easily see so.
Okay. Okay, but try to apply we need to practice KCL and KVL. Okay, so try with this KCL and KVL. Okay, so find out what is so 6 into 3. You're saying 6 into 3. Okay, so this will be answer checking also. 6 into 3, this will be 9 plus 8. Okay, so it's 2 plus 8, it should come 10. I1 should come 10. Okay, correct? It's not coming. What is the issue? 8. So problem is correct. V3 6. Okay, so 6 or 8. It's 8. Okay, 6. Okay, let's try with KCL and KVL, and you can try other way also. See how much answer is coming, because I am getting some different answers.
Sir, I1 3 na? Okay na?
I1 is 3. Yes, I1 is 3 ampere. I1 is 3 ampere. I1 is 3 ampere, correct. So you can apply KCL now. Okay, you can do it for KVL with KVL.
I3 is 1.
I3 is 1, correct. I3 is 1.
And I2 is 2.
I2 is 2, is correct. Okay, so you have calculated directly. Okay, please try to calculate with this KCL and KVL also. So this will be minus 30. Okay, plus V1, and this will be plus V2 0. Okay,
Yes.
so what is V1? So, and you know the relation here, your I1 is minus I2 minus I3 also 0. Okay, so minus 30. What is V1? V1 is 8 I1. Okay, and V2 will be your
3 I2.
3 I2 equals to 0. Okay, so from here you can write I1 value. I1 value is 30 minus 3 I2 upon 8. Okay, and if you apply here also KVL. Okay, so if you apply KVL also here, that will give you minus V2. Okay, and plus V3 equals to 0. That means V2 equals to V3, and your V2 is your 3 I2. So this will give you 3 I2 plus 6 I3. Okay, so from you can get here I3 equal to half I2. Okay, so you know now I3 in terms of I2, I also you know in terms of I2. Okay, you can substitute here this value here. Okay, and you can find out the value of this one. This is I2, so you can find value I2. So this will come as 2 ampere. Okay, I1 will come 3 ampere, and I3 will come
1 ampere.
as 1 ampere. Okay, so you can choose. Okay, if you're comfortable, if you know you have enough practice of the KVL calculation, then you can solve directly. You find out the voltage. You calculate the total resistance of the circuit. Okay, then divide this total voltage by total voltage divided by total resistance. That will give you current. okay, and then you can do it other way also, okay, and both these are parallel, so you can do it other way also. So this was for today's. I'm giving one homework, okay, so just try that question.
Please repeat the
सर एक क्वेश्चन था पहले वाला, उसका सर आंसर नहीं मैच किया था
कौन सा वाला
सर? जिसका मतलब जिसमें दो सीरीज में रेजिस्टेंस दिए थे,
वैल्यू कितना निकाला था आपने
3 ओम और वोल्टेज दिए थे 20 ओम।
वोल्टेज दिया था 20 ओम का, तो कोई क्वेश्चन
V1 8 ओम।
हाँ हाँ हाँ, फर्स्ट क्वेश्चन दिस वन ना, दिस वन।
सर
हाँ ये वाला बोल रहे हो, ये वाला बोल रहे हो?
हाँ सर, हम बोल रहे हैं 20 - 2i + 3i लिख सकते हैं इक्वल टू 0।
कितना?
20 - 2i + 3i।
22i, यहाँ ऑलरेडी माइनस उन्होंने दे रखा पहले से, ओके, उन्होंने क्वेश्चन में दे रखा
प्लस 3i
प्लस 3i, okay,
इक्वल टू 0।
just let me check, okay, so this is plus, this plus minus, so again it is going from minus to plus, okay, so this become plus, yes, okay, इससे तो गड़बड़ हो रहा है ना, so this should be, just let me check, okay, so let it be like this. If you want to apply in this way, okay, so you apply your own current, okay, so say this is 20, okay, then you this is minus 2i, okay, say this current is coming, say this is positive, this is negative, so this will be minus 3i equal to 0, okay, so from here you can get 5i equal to 20, so i equal to 4, okay, so now when you, so you're applying your own convention, so जितना भी वोल्टेज आएगा उसको आपको रिवर्स कर देना है बस, अगर इसको फॉलो नहीं करना है तो जो भी आपका
ओके सर, वोल्टेज का पोलैरिटी का,
हाँ वोल्टेज का, सो यू हैव टू चेंज जो भी आंसर आएगा,
ओके सर, आई अंडरस्टूड,
ओके, हाँ, so there's one more problem, okay, for homework for you. So if any problem, okay, you can again consult me for tomorrow, go through these problems. 10, this is 8 ohm, okay, this plus minus 30 volts, this is 2 ohm, and this is Vx and Ix, okay, so find Vx, that is the value of Vx. So I'm stopping here, okay, we'll meet tomorrow, you go through this all problems, okay, if you have any confusion we'll discuss in next class. Thank you very much.
Thank you, sir.
थैंक यू सर।